Remote-controlled lasers have been entering their operational stage as the result of the recent development of high-quality individual lasers having a high output. Matsumoto Kikai has focused on the superiority of this technology and has been studying it since the early stages of its development. Let's take a look at part of this technology. The verification system used is based on the combination of a made-in-Japan welding head and a high-trajectory 6-axis Revolute robot, designed taking into consideration practicality and maintenance friendliness. Here we look at on-the-fly welding with almost negligible air cutting time, and an inline process monitor that implements real-time weld defect detection. First, let's look at the verification of the performance of the high-speed, high-accuracy remote head. Here it is rendering variations of small and large circles between 3 to 190 millimeters in diameter, with a 15 meter per minute mirror speed within a 200 millimeter diameter circle. As the displacement between the circular arcs is conducted by photon scanning instead of by movement of the robot, the machining position can be moved instantly, and the subsequent reduction in takt time realizes a cost reduction. Next, we show high trajectory accuracy with high speed rendering. Conventionally, a higher speed causes the actual tracing to shift from the teaching line. However, this system implements high trajectory accuracy by using photon scanning technology. Here we show verification of letter rendering. This system can render letters and numbers, and thus it can be used for marking part numbers on your products. The laser can render very small letters. Here the system is rendering on a 50 mm by 100 mm plate at a mirror speed of 15 meters per minute. Now we show on-the-fly welding. This system realizes perfect synchronized movement by integrating the robot's axis control and scanner control. You are now looking at C-type, clip type, S-shape, straight line and wavy welding patterns, which are often used for stack welding. As you can see, there is almost no air cutting time, and the beam on time is almost equal to takt time. Next we show on-the-fly welding on an inclined face. The program can be set by the robot controller, which reduces the labor hour load on a production site. Here a power check is being performed. Let's measure the actual power using a power meter with a command value of 3 kilowatts. Using quantitative laser beam data helps forecast maintenance time and reduce the risks of machine trouble. Next, let's look at the inline process monitor as a real-time quality control tool. This device monitors the condition of welded areas in real time and measures the plasma and temperature on a product and the reflected light. This system identifies weld defects and product defect based on a present threshold graph of a good product. This is the monitoring screen. If the monitored result is between the upper and lower threshold limits, the welding is deemed good. As a monitoring sample, we will show you good product welding. You can see the result is shown between the upper and lower threshold limits. Next, we show the gap between plates. Here we set the gap between the plates at 0.3 millimeters and leave the other parameters unchanged. The quantity of plasma and temperature on the product was lower than the lower threshold limit, and you can see the welding result is no good. Next, we show welding on a dirty surface. We applied a colored paint between the plates and product surface and left the other parameters unchanged. The reflected light is out of threshold range, and you can see the welding result is no good. The last item is changing the amount of power supplied. Here we changed the power from 3 kilowatts to 2.5 kilowatts and left the other parameters unchanged. All the values are out of threshold range and the welding result is no good. As you see, by monitoring the laser welding process in real time, the condition of the weld can be determined based on the monitored value, and process defects can be pinpointed, which helps with a quick assessment of welding results. Matsumoto Kikai is developing a total system solution that provides system upgrading, adjustment and training, including a production control system such as an inline process monitor, in order to introduce and operate a remote laser, which is coming into the operational stage for laser welding productions.